Course 3, we're going to work with a percent of increase and a percent of decrease today as we dilate or grow in dimensions or reduce, get smaller, decrease dimensions. And it might be a little bit challenging at first to get your head around, but I think with some practice, everyone can be successful here. What you really, in the end, need is this box today. It reminds us that when you dilate, the percent of the original is original percentage plus, so it's going to be more than 100, the percent of increase, as in this square is 20% bigger than this square. So what is the percent of this square represented in this square? If this is 100, right, that's the original, we add the percent of increase to get square, we'll call this square 2, is 120% of square 1. That's how I say that. And if you want to reduce, you take the original and then you subtract the percent of decrease. As in if I have a towel and it shrinks by 10%, all right? So I've got a towel here. And the new towel is actually smaller. If this is, right, we think of this as 100%, it's the original. You, according to this box, subtract the percent of decrease, which is 10%. It shrunk by 10% to show what the new percentage is, 90%. Okay? Now, let's get back to example 1 here. One square is 50% larger than another. So not just 20, but 50% this time. We're going to need examples eventually, so I might as well make one now. 1 and 2, good enough. Okay, the perimeter of the larger square is what percent of the perimeter of the smaller square? Well, let's write down our percentages. Remember, this is 100. And this square is 100 and plus the percent of increase, 150% of that square. Okay, what we need when we work with this is the scale factor. Do you remember that term? Scale factor is the factor that we multiply by to get to new dimensions. So if this were 1, what would I need to multiply by to get to 150% of 1? What's the scale factor? The scale factor is the percentage changed into its decimal counterpart. 150% is really worth, right, percent or 1.5. The scale factor is that, 1.5 you multiply by to get new each dimension. So this is 1.5, this is 1.5. Okay, now how does the perimeter change? The perimeter is a strict multiply by the scale factor. So if this is 4, you just have to multiply the entire perimeter times scale factor exactly to get to new perimeter. So it should just change by the 150%, or for 1.5, or it asks for percent, so it's just the scale factor. It's just changing the percent up here into, well, using that. Now in letter B, it asks area. The trick with area, because it's in 2 dimensions, is just take the scale factor and square it for 2 dimensions. So if 150% is the percent of the original in the dilation, 1.5 is the scale factor, and then 1.5 squared, which I think is 2.25, is the percent, well, it's the scale factor for the area in 2 dimensions there. So then change that into a percentage by multiplying back by 100, and it changed 225%. And we could test that by doing 1.5 times 1.5, you get 225, or 2.25. But 1.1, or sorry, 1 times 1 is just 1. So, 2.25 divided by 1 shows that it changed 2.25. All right, so we did A, B, and C. In review, when they gave you this, that means that the overall percent of the original is the 100 plus 50, so it's 150%. Perimeter changes the same as what we just said. Now, but in letter B, since it's 2 dimensions, you square the scale factor and then turn that into a percent by multiplying by 100, and then you just draw it out as close as you can. Let's try reducing now. Towel shrunk 10%, so the new one is 90% of the perimeter. How does area change? We just talked about this. Take the scale factor, which is 90, because percent of original is 100 minus 10, so we don't really need to use the 10 again. 90%, so what's the scale factor? 0.9. Remember how we find percent area changes? 2 dimensions. I think that's 0.81, right? 9 times 9. Turn that into a percent again. The new one is 81%. The area, sorry, so this is like thinking of the perimeter. Now, area is 81%. It's even smaller. Now, careful. You'd be tempted to put 81%, but it's 81% of the original, the area is. And it asks what it reduced by. So you got to take 100 minus 81. It's 81% of the original, but it reduced by 19%. And then our examples are here. We could just say that this towel was 1, so like 1 foot maybe. So this towel is 0.9 feet. And if this towel is 2, then this towel 2 times 0.9, 2 times the scale factor, is 1.8. And that's our example. And we could even test this again. 1.8 times 0.9 is the new area. 1.62 should only be 81% of a full 2. I know I'm talking through a lot of things, and every time I review it, I don't think I make it much simpler for you, but hoping it makes some sense. Let's just talk about example 3. It gives you vertices of a square, 4, 4, 4, negative 4, negative 4, negative 4, and negative 4, 4. When you draw it out, it might look something like this inside square here. And then they say dilate it. 125%. If it's easier, you can do it on a different paper, but they did it all on one. So what we need to do then is count how big is the original. 1, 2, 3, 4, 5, 6, 7. It's got 8 units across, because it's from negative 4 to 4. 8 units here. Let me use my pen. If this is 8 units and it changes 125%, or a scale factor of 1.25, we multiply that. Am I doing this right? Make sure I got the right perimeter. I think it's saying that the perimeter is only 4. One, 2, 3, 4. 2, 3, 4. I don't understand why this isn't 8 times 4 is 24. But regardless, what you need to do is find the length of a side, multiply it by 1.25, and then make it that long. Okay, and then answer the questions. I think they maybe miscounted on that. I could be wrong. But thinking about it, I think the perimeter is 24, not 16. We can look at that more in class. Example 4, if the dimensions of a cube are increased 100%. Okay, so let's just start there. We got a cube here. Always use 1 to keep things simple. If it's increased by 100%, why is it 2? Because, remember, percent of original is 100% plus the increase, which is another 100. It's a 200% increase. Change that into, divide by 100 to use it. That's 2. So to find dimensions, you multiply by 2 for a scale factor. 1 to 2. If we asked, how does that change area, you would take scale factor squared, which is 4. But since they're asking volume, how many dimensions is that? That's scale factor to the third, 3 dimensions. That's 8, or 800%. Since they asked increase, just like when we did the towel, we have to subtract off the 100% that it started at. It's 800% of the original, which is an increase of 700%. All right, we might have to talk this over a little bit in class. Hope it makes some sense for you. Let's try B and C.